Hello, and welcome to this introduction to the N3C Data Enclave. My name is Sean O'Neill, and I'll be your narrator today. The Data Enclave is a secure, cloud-based platform for data analysis and visualization loaded up with hundreds of millions of patient health data records related to the COVID-19 pandemic in the United States. The Enclave includes various datasets with different access levels, data analysis tools, and a variety of other resources specific to working with N3C data. These are organized via a complex interplay of projects, data tables, data catalogs, request forms and processes, analyses and results, documentation, and so on. Here we're going to review these resources and organization at a high level to get you started. But just so you know, we won't be able to cover critical aspects of data analysis itself. We'll be leaving those to future videos. So let's start with the first thing you'll see after logging in, the Enclave homepage. If this is your first time logging in, you'll see some terms, conditions, and disclaimers. You can review these in the different tabs and dismiss the dialog by clicking Accept All. After you accept, it won't pop up again, but you can always access it again via the Terms and Conditions link in the main menu of the homepage. Along the top of the homepage, other links provide some more information about the data, summary of training resources, and so on. Before we get too far, I do want to review the support and contact page. There are two primary ways to get help with N3C, one which lives outside the Enclave and so is available even to those without Enclave access, and one which lives inside the Enclave. If you have a question about N3C generally, whether it be about getting access to a Google group, checking on the status of a data request, or difficulties logging in, you should use the support desk option shown first. However, any issues regarding the data itself, which might involve information about patient data, should be submitted within the confines of the Enclave. For this, you can submit an issue or question via the Help and Support menu in the lower left of the interface. The most important resources of the homepage are on the landing page, so let's go back there. Along the top are some big blue buttons which pertain to your specific research projects in the Enclave. We'll return to those in a few minutes. Below that, we've got a small dashboard summarizing the data ingested into the Enclave so far. Up to now, we're at just over 1 billion rows of data, representing almost 1 million people, 121,000 of whom were identified as COVID positive, though notice that there's a little star here with information in more detail down below. We can also click the link here to get a more detailed dashboard and a new tab with some summary statistics about the patient population. Going back to the home page, we can see that all of these data are coming from 20 sites and more are on the way. As the sites collect more data and ship it along, so too will the N3C dataset grow and evolve. In fact, these data releases are versioned, so older versions of the database can be accessed for reproducibility reasons. The data being collected from these partner sites come from a variety of database organizations. Some sites store their data using the TriNetX platform, others use pCoreNet, and so on. To collect all of this data into a single database, a common data standard is used known as OMOP, which is short for Observational Medical Outcomes Partnership, and is developed by a community known as OHDSI or Odyssey, the Observational Health Data Science and Informatics Program. Because so much of N3C revolves around this OMOP standard, including where and how data is organized, it will help to very briefly introduce what the data look like. As you may know, having access to the Enclave does not automatically provide access to any of the 3 secure tiers of N3C data. What it does provide, however, is access to what we call SynPUF data, short for Synthetic Public Use Files. These are data tables based on publicly available data that's been formatted into the OMOP data schema. We've taken these and aligned the tables and columns, but not the data itself, with the more sensitive datasets. So let's go there and take a quick look. The basic way data are organized in the Enclave are projects, which we can find by clicking on the Projects and Files link. The SynPUF data files can be found in the Notional Data project, which is down near the bottom of the projects list, inside the SynPUF OMOP folder, inside of the SynPUF Schema Alignment folder. Don't worry, we'll see in a few minutes other ways data can be found and organized. Let's look at the person table where each row describes a patient. Some of the columns we see are person ID, an identifier associated with each person, and their gender encoded as a gender concept ID. Concept IDs are identifiers which are described in another table called the concept table. That table contains an entry associating 8532 with the term female. Normally, people working with OMOP data need to connect these two tables together, but at N3C, we've done this for you by including a corresponding column called gender concept name near the end. There are similar linked columns for ethnicity and race concepts. As mentioned, though, the data are different from the real data. For example, in N3C data, there are no information in the month of birth and day of birth columns. There's a column in this table which we've added to match that of the N3C table, which describes data partner ID. In the SynPuff data, these are all nulls, but in the real data, those will be containing an ID indicating which data partner site each individual row comes from. Next, let's take a look at the condition occurrence table, which describes patient conditions like diagnoses. I'm going to sort this table by the condition start date. Notable columns here include the person ID, which matches entries in other tables, the condition concept ID, condition start and end date, and so on. As before, there's a condition concept name column with the human readable version of the concept ID brought in from the concept table. There are a couple of specific things to mention about the N3C OMOP data before we get back to the enclave generally. First, note that it's not a good idea to try and select rows of data by text searching the concept name columns. For example, we can see here an entry for congestive heart failure as an option. We're also likely interested in other kinds of heart failure, but they may not all include the words heart failure. This is particularly important when looking at drugs which come in many doses and names. Rather, it's better to collect a set of concept IDs of interest, making use of the fact that concept IDs exist in a hierarchy of relationships. We call sets of concept IDs a concept set, and we'll see what those look like soon. The second specific thing I want to mention has to do with dates. In the N3C Level 2 data, also known as the de-identified or safe harbor data, dates have been randomly shifted to protect personally identifiable information. Fortunately, each individual person's dates are shifted by the same unknown amount. So even after date shifting, we'll be able to see what events happened on the same date or search for events near each other in time as they relate to the same patient. In browsing these two tables, we've discussed concept IDs and concept sets. Let's go and see those for a bit more insight. However, even though these tables also exist in projects, there are quite a number of projects, each with various folders, subfolders, and different organization. As a result, outside of your own research projects, it can be difficult to find things in the enclave. This is where the data catalog and data collections come into play, which we can find under the Projects and Files link as well in a different tab. A data collection is just a set of links to some files in one or more projects curated to be just what's important. For example, the SynPuff synthetic data collection links to just the tables of interest from the notional data project we were just in. And similarly, the Safe Harbor data collection links to the same tables in the Level 2 data. And if I had access to the Level 3 limited data set or LDS data, that would show up here as well. To see the concept table defining concept IDs and concept names, we can open up the OMOP concepts data collection. Opening the concept table, we can see that there are about 5.5 million concept IDs with corresponding names and domains. Domains correlate with which data or other tables the concept will be used in. We also see a column for standard concept. This table includes codes from many systems such as ICD-9, ICD-10, and others, but those source codes shouldn't generally be found in the concept ID data columns unless they are chosen as a standard, or they are used only for classifying other concepts, in which case they are labeled with a C. C concept IDs should also not be found in data since they are meant to collect groups of other concepts. If you're familiar with a given ICD-10 code, though, it's possible to look up the corresponding standard from the concept relationships table, which we'll look at next. You won't generally need to work with non-standard concepts, as incoming data are mapped to these common standards, which is largely the point of OMOP. It's worth noting, though, that in N3C data, this mapping process differs depending on the format of the source data coming from the different sites, resulting in some occasional differences in which concept IDs are used between sites. Now let's go back to the OMOP concepts collection via the link up here in the upper left and take a quick peek at the concept relationship table, which describes relationships between concept IDs. If we filter the Concept ID 2 column, we can search for concept ID 4288310, the standard ID for carotid artery obstruction. We see that concept ID 1569202, right there, maps to this ID and so is not a standard. Whatever 7622926 encodes is a special kind of carotid obstruction, and 4102928 is a more general concept that includes carotid obstruction and possibly others. Hopefully now you can see why curating sets of concept IDs, or concept sets, is an important part of data analysis. To understand how concept sets are stored in the Enclave, let's go to the OMOP code sets data collection. This data collection contains just one table describing concept sets that have been defined by N3C users. Let's sort by concept set name to see what's in here. One concept set, urinalysis protein, has just a single code set ID of 905404327, but contains 6 different concept IDs. The concept sets are also versioned. This set has only one version, and it's the latest, as indicated by the trues here, but the set above it, urine potassium, has 2 versions, only one of which is the most recent, and each of which have different code set IDs. Now you may be wondering, how can I create my own concept sets? You definitely won't have to work with the raw concept and concept relationship tables to do so. There are tools to help you create good concept sets covering exactly what you want, but those are beyond the scope of what we can cover here. Additionally, N3C is creating a review process for these concept sets, so subject matter experts can vet concept sets as appropriate for use by multiple teams across N3C. Let's take a moment to review what we've covered so far. First, we looked briefly at the Enclave homepage. We also looked at projects and files, specifically 2 SynPuff data tables from the Notional Data project. And we looked at data collections and saw a few data collections of interest. There's the SynPuff synthetic data, which contains data tables of publicly available data. There's the Safe Harbor data, which has the same tables, but actual N3C data sourced from many different sites. There are the OMOP concept tables, which describe concept IDs and concept names, and the concept relationships are stored in this data catalog as well. And then finally, there are the OMOP code sets containing defined concept sets that can be used for analysis. You're of course free to browse around all the other data collections that you have access to as well. Since we've just been talking about OMOP concepts and concept sets, let's quickly take a look at the Object Explorer, which provides a graphical look at some of the data contained in these tables. These tools are specific to the kinds of data they are tied to. For example, the N3C admin section is tied to tables about users. The OMOP data section shows concept sets and concepts. Let's browse concept sets in this particular interface. Initially, we see a summary of all the concept sets, but we can also search by keyword, for example, urine. Clicking the urine potassium set shows the versions, properties, and review status. We can click on a particular version to browse the included concepts. This browser is helpful for creating, reviewing, and searching concept sets, but you should know that for analysis, you'll be using the table of concept sets we saw earlier. Now let's step back and take a peek at how research projects are created and organized. Individual research projects are also projects in the Enclave, and individuals are given access to these projects, and in turn, projects are given access to data via references, sometimes called imports. A figure may help. The pregnancy-focused research project may contain analysis files, folders, and so on. When it is created and approved for Level 3 access, the data tables from the LDS data project are added by an administrator as references which can be accessed by analyses in the project. Of course, other research projects may access other levels of data in the same way. And then there are projects with data available to all, such as the Notional Data project containing the SynPuff files. In the middle of all this is a user. Users access projects via roles, 3 of which are Collaborator, Explorer, and Viewer. The Collaborator role is more or less what it sounds like, allowing a user to see, edit, and create things inside of a research project. The Viewer role lets someone view the contents as well as create references to files inside. This lets a researcher link data into their research projects as they like. The Explorer role, however, lets someone view the contents of the project but not create new references to the contents inside. This prevents researchers from linking sensitive data in where it shouldn't be. In a similar way, being a collaborator doesn't enable linking in, so it's also not possible to make cross-project references that would expose protected data. There's one more security aspect worth mentioning, known as markings. Secure data can be marked as such, and in order to see that data, or any result dependent on it, the user must also have the same marking, no matter which project it is in. In this example, the user would be given markings for both Safe Harbor and LDS data, allowing access to the data and derivatives of it. But if the LDS marker is removed from the user, they automatically lose access to those despite their various project roles. So, how do you get these markings in project roles? Well, you have to request access with what's known as a data use request, or DUR, which are then reviewed by a data access committee, or DAC. There are a few ways that this could happen. One, if you want to create a new project as a project lead, or two, if you are invited to a project by the project lead, or three, if you request access to an existing project, in which case your request will need to be approved by the project lead and the data access committee. These big blue buttons on the Enclave homepage deal with these DURs. Under See My Projects, we can see the projects we've requested access to and invites from project leads. The Data Use Request button is best suited for a brand new DUR submission where you want to have a new project created with you as the lead. And in Explore Projects, you can browse through all N3C research projects and you can request to join those that allow it. First, let's look at the DUR, supposing we will wish to create a new project as the project lead. The Enclave knows my name and email, so those are pre-filled, but we'll need to enter a project title and abstract. Be aware that these will be made public both inside and outside of the Enclave. The project rationale is available only to the Data Access Committee and should include a justification for the level of data access being requested. We can choose to let others request access later if we want, and we can invite collaborators now. Note that all collaborators would need Enclave access, and they'll have to fill out parts of the DUR as well, which we'll see in a minute. Next, we can choose which level of data we want to be linked into the project. Level 3 data contains full patient zip codes and accurate dates, but requires a local IRB approval and is only available to US-based researchers. Level 2 data contains just the first 3 digits of patient zip codes and dates are randomly shifted, but doesn't require IRB approval, just recent completion of human subjects research training, and is available to qualified non-US researchers. Synthetic data is a work in progress and will eventually contain data designed to be statistically similar to the LDS data. Synthetic data will be available to citizen scientists, those without a research organization to affiliate with, but all levels require completing some online NIH security training. After choosing a level like Level 3, we'll need to read and attest to some agreements, and potentially upload the IRB determination letter for Level 3 access, and then we'll be able to click Submit. Once our request is submitted, it goes in a queue for the Data Access Committee to review. If we navigate back to My Projects, we can see submitted requests and their status in the top panel. Here we see that I've got one complete and one has been accepted by the Data Access Committee, but I'm waiting on a project role to actually visit the project in the Enclave. Down below, I can see a project invite to the Pregnancy Research Project. The project itself has been approved by the DAC as shown by the green approved label, but my participation is not yet approved. To request DAC review, I can click to submit a collaborator request from the invite, which will take me to the DUR partially filled out. It has project information and data access level set, but I need to attest and upload my IRB determination letter to submit the request, after which point it goes in the DAC review queue. Going back to my projects list, if I were to request access to an existing project, I would need to be approved by the lead and the DAC. Leads can do their part by clicking Review Collaborator Requests for your projects. I don't have any to show, and notice that there's also an Appeal button near the top of the My Projects list if you think the DAC has come to a wrong decision. Finally, let's go back and explore projects. There are three panels in this view. Projects that we can request to join up top, and those we can't in the middle. Note that these scroll, and you'll need to scroll to view all of the rows and columns. Down below are some operational projects, and be sure to notice the search bar up on top, which can make it much easier to find the projects that you're interested in. Columns can also be sorted in these views. Before we move on, it's important to note that if you do want to join an existing project, that you do it here via the Request to Join link in the list of existing projects. You might see other Request to Join buttons in other parts of the Enclave, but this is the only spot that actually makes it work correctly. Let's move on and talk about tools or applications. The Enclave includes a number of powerful tools to work with and analyze data, but we'll just give a brief summary of a few of the important ones here. First up is the Contour application, a user-friendly but powerful graphical interface for filtering, merging, and modifying datasets, as well as producing basic visualizations like histograms and heat maps. Although not code-based, even experienced coders may want to use Contour for initial data filtering and pre-processing, since Enclave-specific issues like Apache Spark data frame operations are automatic, resulting in tables that can be saved for analysis in other tools. Code workbooks provide an interface for processing data with SQL, R, Python, or a mix of these. A large number of Python and R data science libraries are available, but if you need more, you'll have to ask for them to be installed. When working with code workbooks, the Spark-based nature of the Enclave is revealed. You'll need to work with the PySpark or SparkR libraries and convert data to and from Spark data frames as needed. Reports can contain text and images, as well as data visualizations produced in other tools, though you can't perform analyses in reports themselves. Reports are easy to author and even allow others with access to add comments, providing a means for feedback and conversation about results. Reports are also a nice way to author quick tutorial documents. Next, let's talk about code repositories. Note that some applications may not be shown by default in the left navigation bar, but you can see all of the applications by clicking on the View All link and then starring the ones that you want to keep present on the left navigation bar. Code repositories are another interface for writing code, in this case in either Java, Python, SQL, or Mesa, which is a SQL-like domain-specific language. Like code workbooks, they are oriented toward data table transforms, but they provide versioning, collaboration, and branching features of Git in an Enclave-based interface. Because the code bases are executed by the Enclave as data processing jobs, they must conform to specific code organization and libraries. Finally, let's take a quick look at the data lineage tool, also known as Monocle. Monocle lets you explore what inputs are used in an analysis or help to create a piece of data and where that data is used downstream. This can be used to discover the provenance of a result or explore what else is happening in the Enclave that you happen to have access to. We've already seen the Object Explorer when checking out concept sets, and it may be worth mentioning Fusion, a spreadsheet-like tool for data analysis that unfortunately is limited to importing only up to 2,000 rows of a given Enclave table. The last topics for us to cover are where to go to learn more about the Enclave, especially the analysis tools and how to be effective with them. First, know that we'll be expanding our selection of training resources like this one, so keep an eye out for announcements. The Enclave includes a robust set of documentation which can be accessed under the lower left Help and Support menu. Documents are organized by application and can provide useful insight into the confusing user interface elements or features you run into as you're working. Obviously, you'll want to read some sections completely, but I also want to highlight the search bar up above where you can search for specific keywords like contour parameters. And that's it for now. I hope this has been a useful introduction to the N3C Data Enclave data and tools. What we haven't covered is perhaps the most important topic of all, how to effectively analyze N3C's OMOP formatted data, complete with data filtering based on concept sets. That's a larger topic than we have time for now, and some of the tools for working with concept sets are still being developed. In the meantime, if you want to learn more about OMOP, check out the Eden Academy videos available at academy.ehden.eu, particularly the courses on the OMOP CDM and standardized vocabularies and the Atlas tool. You'll need to create an account here but the videos are not long and they're well worth your time as an N3C contributor. Thank you very much for watching, and we'll see you in the Enclave.